welcome to this session. My name is Carlos Sanchez, and I'm going to talk about scaling Jenkins with Docker, Swarm, Kubernetes, Mesos. There are several alternatives to do this, the scaling of Jenkins. So let's talk about that. And if you want to find me, that's csanchez.org. That's my URL, and csanchez is my Twitter. So let's start a little bit about me so you understand where do I come from. I work at CloudBees in the private SaaS edition team. If you were at the keynote, that demo where there was like 2,000 masters running in Docker containers with around 8,000 executors at any given point in time. That's what my team builds. Everything running in Docker, in a cluster. Everything is dynamic. And I also contribute to a lot of the open source projects. I contribute to the Mesos plugin. I created the Kubernetes plugin for Jenkins. And I contribute to the several Docker images, the Maven official one, the Jenkins official one. And I've been working with a lot of open source projects back in the day, Maven, Apache Maven, and Eclipse projects, and so on. So a lot of open source work in the last years. Okay. So obviously, you are all here. Who is using Docker? Raise your hands. OK. A lot of people. Who is already using Docker with Jenkins in some way or another? OK. A lot of people. So Docker, 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 Docker. So this is, I love this quote. The solution, Docker, the problem, whatever it is, the solution is Docker, right? We've all been through there. But using Docker and containers is not trivial. It gets complicated sometimes, especially when you are trying to scale. So when you try to run in more than one Docker host and you want to create a cluster using Docker, then you have to look into one of these cluster schedulers. And typically, you will make a choice for a project that runs in public cloud, private cloud, VMs, bare metal, all of them can run on all these different places. Obviously, you want it to be HA, fault tolerant. You don't want to babysit each of your containers or your hosts. And obviously, you want cluster scheduling with Docker support. That's why we're here today. And the three options we have are Mesos, Apache Mesos, Docker Swarm, and Kubernetes. So let's talk a little bit about each of them. Anyone using Mesos here? Yes, one person. And Docker Swarm? Nobody? And Kubernetes? One person over there? OK. So let's start with Apache Mesos. They call it a distributed systems kernel, basically underlying infrastructure. Well, on top of the infrastructure, the layer that allows you to schedule things in a cluster. You can run Hadoop, you can run Spark, you can run Kafka, all sorts of different workloads on top of Apache Mesos. It was started, it's the oldest one. It was started before 2011, different research papers there. And one of the interesting aspects of Mesos is that it can run anything, any binary, not only Docker images. So back in the day, before Docker was popular, they were already running processes and tasks distributed in clusters. And now they are in support for not only Docker images, but Rocket, AppC, and all these different container images that are standards are getting created. So on Mesos, you have what they call frameworks that are the ones that actually do the scheduling. So if you want, Mesos only does the running of the tasks. If you want to run long-lived processes, you will have to use a scheduler, either Marathon or Aurora. And another very popular framework is Kronos that was created by, I don't know if it was Twitter or Airbnb, created this like distributed cron system for tasks that you would run across the cluster. So, and Mesos it's very popular because it's been around for longer, and it's being used on Twitter, Airbnb, eBay, Apple. It uses it for Siri. It's used everywhere. The other option that is more recent is DrStorm. So from Docker Inc. And it uses the same Docker API that you would use in a one-host Docker server. And in this way, you don't need to modify your existing tooling. And the Docker Swarm, you would execute the same CLI against the Docker Swarm that against a single Docker host, and it would automatically distribute your containers. So another thing that they came out with Docker Inc. Just recently is the Docker Engine Swarm mode. I think it's called Swarm Kit, where it's new in Docker 1.12, where you don't need any extra features. Just your Docker daemon is going to run as a Docker Swarm, as a cluster. So it has this benefit that all these hosts running Docker auto self-organize themselves into a cluster. You just basically say, join this cluster, and they all start communicating between each other. So it's very convenient. The problem is to run things on this new Swarm mode, you need to use a different commands and different APIs. Basically, you have to run services, what they call services, which means none of the existing tools are going to work because they need to be changed to use the new APIs. So any of the Jenkins plugins that are out there for Docker don't work with Swarm mode. And Kubernetes it was started by Google, open source project too, and it allows you to run in local machine, in virtual, in cloud, and the reference implementation, as we may say, is Google Container Engine, where you can just go in through the Google Cloud interface and say, I want a cluster, and Google will start it for you, and it will set up everything correctly. But you have other companies doing that. Like StackPoint allows you to, I think it's like adding your credentials for any other cloud, like Amazon or Azure, and they will create your Kubernetes cluster, because these clusters are not easy to set up. So there's a lot of things involved, like you need the compute, the VMs, you need the networking layer, the storage layer, all the stuff. And also another interesting thing that Kubernetes, or a side project of Kubernetes, is Minikube, that you can use to create a local Kubernetes cluster in your local machine. And so it's very easy to use for testing. So let's go into the Jenkins world a little bit more. In order to scale Jenkins, you have two options, right? There's more build agents per master, or more masters. So if you want to do more build agents, there's a lot of plugins that allow you to do that. Not only with Docker containers, but cloud providers, creating VMs, and basically in any imaginable way of creating new Jenkins agents. The problems we have with that is the master is still a single point of failure. And the master has some limitations, like the configurations that you can have. I mean, each master has a definite set of plugins and plugin versions. So you cannot have multiple plugins installed or multiple plugin versions installed at the same time in the same master. And also there's a limit on how many build agents you can add to a master. That limit is pretty high, and every time it's higher and higher. There was some other talks about how far you can go creating agents, but it's still there. And the other option is creating more masters, where the benefit is you have separate master for different like teams or parts of your organization, departments, and they can like self-organize themselves, install whatever plugins they want, have whatever custom configuration, and so on. Obviously, the problem we have when you have a bunch of masters running, if the number grows, then it becomes a pain to be managed. There's no, like, you would need like single sign-on or something like that to be able to log to all of them. And you would need some way to centralize the operation of all these masters in a reasonable way without going crazy if you have a large number of masters. So these are this configuration is covered by CloudBees Jenkins Operations Center that you can talk about it with somebody in the booth later, or and also what we built is the CloudBees Jenkins platform, Private SaaS Edition. It's like a combination of both multiple masters with dynamic agents, and it has kind of like the best of both worlds. But what I'm going to talk about today on this session is going to be the previous option, how to scale with more agents dynamically using Docker. And I love this quote, to make errors human, to propagate error to all servers in an automatic way is DevOps. This is the DevOps Borat Twitter account. So this is I think this summarizes it pretty well, the level of automation we want. And a quote that I just made up after this weekend preparing the demo for the keynote is like, if you haven't destroyed something automatically, it's like you are not automating hard enough. Your automation is not up to speed to what you want to do, right? If you have a good level of automation, at some point in time, you have destroyed something that you shouldn't. So this has happened. I'm not going to go into details yet here, but happened. But like getting locked out of machines because you change some Puppet configuration, and then it gets automatically deployed to all the machines, and then you're like, oh, shit, I cannot log in again anymore. Well, that's the level of automation you want. But you want it right, but that's the level of automation you want. So running in Docker, anyone here using the Jenkins Docker images? Yes? I would hope everybody using Docker is using the Jenkins images that we provide, both open source and there's also the CloudBees versions. So there's a Jenkins repository in Docker Hub, and that provides the latest LTS release. And we keep updating it all the time. So if you just do Docker run Jenkins, that's what you get. You get the latest LTS. There's another repository called Jenkins CI/Jenkins that provides weekly builds. So if you need a specific build for whatever reason that you don't want to be on the LTS, or you want to try something, that repo gets automatically built continuously, and you can go to the tags and pick up whatever version you want. There's other related Docker repos under Jenkins CI org. We have the JMLPS Life, which is the Docker image that contains the Jenkins slave jar file. And basically, if you run this Docker image with this command, you automatically get a new slave connected to your Jenkins master, right? So this image is used by some of the plugins to just create this image dynamically in Docker and get more agents. There are some other interesting images out there, but let's start with these two ones. So I was talking about cluster scheduling. What do you want from your cluster scheduler? You want to run isolated build agents, and you want to run isolated jobs, probably using some sort of caching too at some point. You want to use Docker, so you can reuse all these Docker images that are created by somebody else. And you want it in some way that, like capabilities are dropped, so somebody running a build doesn't have permissions over the whole host or things like that, right? That's the whole promise of Docker and containers and so. The dynamic scalability and isolation. And one interesting functionality that you may want is grouping containers. So let's say you want to run a job, and you want to run a Maven build in that job, and you want to do some Selenium testing. So instead of cranking up a Docker image that has everything baked in, which basically forces you to create your own images, you may want to do grouping, right? You want to use the Jenkins agent as one container. You want to use the Maven image as another container. You want to use the Selenium Firefox image as another container, and the Selenium Chrome, and the Selenium Safari, and reuse all these different containers, like 5 containers in this case, well, actually 6, and reuse all the images that are already published in the Docker Hub, and not having to create your own image. So that's one of the features you probably want. And out of the 3 schedulers or clusters, so Mesos has it in progress. There's an issue to add container groups to Mesos. Docker Swarm, I'm going to talk about the old Docker Swarm, not the new Swarm mode in Docker Engine, because it's not supported in any of the plugins yet. So Swarm supports grouping through Docker Compose. So if you run Docker Compose against a Swarm cluster, all the containers in that Docker Compose definition are going to be started in the same host. But you can also force the execution of some Docker containers in the same host as other containers. For instance, using volumes from and other of the options of Docker. There's a list of what options are going to make the Docker Swarm schedule that container where another container is running. And Kubernetes was the first one adding this concept of container groups. So in Kubernetes, it's called pods. And this was introduced from the beginning. And basically, it's a definition where you have multiple containers, and Kubernetes ensures, or by definition, that pod is going to be executed in the same host. So if you have a pod where you have like, Maven and Selenium and this and that, it's going to guarantee that that pod is going to be executed in the same host. And another interesting feature that it has is like, all those containers can access the port on the other containers in the same pod using localhost. So if you have a Maven build, a Maven image, and a Selenium image, the Maven image can talk to the Selenium server running on the other container. The Maven container can talk to the Selenium container using localhost and the Selenium port. So that makes it really convenient for some use cases. Memory limits. Obviously, you can run things in a cluster without telling much to the scheduler, but you probably want to say, hey, this container that I'm running requires this amount of memory, so make sure you run it in a host that has that amount of memory available, and also make sure that it doesn't go greedy and take more memory than this amount of memory, because otherwise my other jobs or other containers are going to get penalized. So in Mesos, that kind of gets required by the definition. In Swarm and Kubernetes, you can define it. And this constraint relates to the Docker options, that's memory. So this is an interesting problem that a lot of people kind of don't realize until they're running things at the scale. So what do you think happens when you run a container and you set a quota and your container runs out of quota, like in a Java application? So any people using Java here, I guess? So what do you think happens when you run, you set up a container and say, I want this to have, I don't know, 128 megs, and your container goes and tries to use more than that? Out of memory exception, somebody says here. So I'm going to show you. It's not going to happen anything good. So let's see. Can you see that? Yeah. So what I'm going to run here, okay. So this is a Maven build with a JUnit test that basically tries to use X amount of memory. And this first run is just a never-ending loop because I'm not setting any limits. So this JUnit test is using some amount of memory, garbage collection happens, keeps using more memory, garbage collection happens, and so on, right? So it's using around 368 megs, whatever. The number really doesn't matter. So the next thing I'm going to do is I'm going to run it limiting the amount of memory in Docker. So this translates to the kernel limitation. The kernel limits how much memory this container process is going to have available. So I'm limiting it here to 192 megs, right? It's here. And I'm running exactly the same Maven build. So what do you think is going to happen? You said out of memory exception. Somebody else says anything else? Any other options? The container dies. Why? Oh, yeah. I know who you are. You're cheating. You already know the answer. So what happens is this happens. So you get nothing. Basically, this is waiting. My script is waiting now. You get nothing there. But let's see. So this is the container. It exited with this 137 exit code, which basically means my process has been forcibly killed. And if I do a Docker inspect and the container, I'm getting this. And there's an interesting field in the definition where you get OOM killed true. So what happened is my container went over the kernel quota that was set by the Docker daemon, and it basically got killed by the kernel with no output whatsoever. So imagine when you're running this in a cluster and you have no idea of what's going on. I mean, if you have to log into each of the host machines and try to figure it out. I mean, it gets hard, right? So this is what's happening. Now, I'm going to run the same thing, but I'm going to set Maven ops, and I'm going to set do not use, I'm telling the JVM, do not use more than 192 megs of heap, right? What do you think is going to happen? This is going to run. It's going to get to the 192. Garbage collection is going to happen, and never is going to go over 192, right? So actually, all right. Now, there is one problem with this definition is like I'm setting the memory for Maven, and this is particularly interesting in the case of Jenkins where you are executing Maven and a lot of processes. So I'm setting the memory for Maven, but I'm not setting the memory for any other process that is started. So the JVM for Maven is using that limit, but Maven, by default, it uses Surefire for running the tests, the JUnit tests, and by default, it forks a new JVM. The new forked JVM doesn't have any of the limits that you set to Maven. So the new forked JVM is going to run out of memory. So that's one problem you have. So you're saying, OK, so how do I do that? Well, how do I fix it? In Maven, you would go and each tool is different. In Maven, you would go to the POM and say in the Surefire plugin section, do not use more than this X amount of memory. You would set the XMX to whatever amount it is. So you just got to be careful because each process, if you don't tell anything to the processes running in a container, by default, they see all the memory that is available in the host. And especially in the case of the JVM, by default, most of the cases, is going to decide, I'm going to use 1/4 of the available memory as max heap, which in my case is going to take the whole memory of the machine and use a big amount, an amount that if I limit in Docker C groups, is going to make my container crash. So there's that. The JVM, the child processes. And now we have also the CPU limits. And you can also, in all of the all of the schedulers, you can also set the CPU limits. Now, what do you think happens when you set some CPU limits and your container goes over those limits? Any idea? Any suggestion? Does the container get killed? No. No, and that's so when it tries to access more than the CPUs that you set, basically in Docker you're saying what share of CPU do you allow the container to use? If your container is the only one running in that host, it gets 100% no matter what you tell Docker. It gets all the available CPU. If you have 2 containers and you say, oh, I want 0.1 CPUs, each container is going to get half and half. So it's a shared setting that basically distributes the CPU cycles. So if you say one container you want a 0.1 CPU and another container 0.2 CPUs, what you're guaranteeing is that the second container is going to get twice the CPU cycles of the first container. But if nothing else is running on that machine, they get the full CPU. And other interesting things that you may want your cluster to do is storage. So distributed. Mesos supports it from version 1.0 with using the same Docker volumes that Docker provide. Swarm, of course, uses the Docker volume plugins. There's a bunch of them with different support for different backends. And Kubernetes also had from the beginning support for persistent volumes in AWS EBS Volumes, in Google Cloud, Google Disks. And I think I'm going to skip a little bit because I'm a bit behind. So problems we found, for instance, scaling. If you try to attach too many EBS volumes in AWS to a machine, well, you run out of letters. Because Amazon tells you that you should only use SDF to SDP on these instances to attach volumes, although up to the letter C it works, you're limited to the number of volumes you want to attach. So if you're trying to run a lot of containers with EBS volumes, you cannot do it in one host. And a typical error with Docker is also the user ID of the container running versus the user ID of the host. And like using something like NFS makes this worse because the users need to match across all the hosts. So make sure always that the user ID of the container that is running matches the user ID of whatever data you are trying to access. Because this is a top question. And also another aspect you have to consider is networking. And the Jenkins masters, you need HTTP, you need JMLP, very important for the agents to connect. And there's also an SSH port for some CLI operations. And you need to make sure that the agents can connect to the masters through JNLP or the masters to the agents through SSH. And in different clusters schedulers, you can have one IP per container and having network virtualization. All of them support it in different ways, like Swarm uses Docker overlay and allows you to, again, with plugins, extend that. Mesos has like network isolators, and Kubernetes also has different options. And I'm going to talk about the support in the different plugins of the three schedulers. So for Docker, you can have dynamic Jenkins agents using the Docker plugin or the yet another Docker plugin. And as I said before, there's no support yet for the Docker Swarm mode in Docker 112. So they basically are the same plugin that runs against one Docker host, can also run against one Docker Swarm because it uses the same API. The agent image needs to include Java because you need Java to run the Jenkins agent. And there's a bunch of different plugins to do all sorts of things Docker, like the Docker build and publish, to build Docker images, and so on. And it has great pipeline support because it was the original one. So how would you define it, a pool of dynamic agents? In Jenkins, you go to the Manage Jenkins, Add Cloud, and if you add the Docker Cloud, basically you are saying, well, tell me where the Docker URL. In this case, if you're running a Swarm cluster, you just tell the URL of the Swarm manager. And you configure the credentials, the certificates, and all that stuff. And then you define what templates you want for agents and associate labels with those templates. So this is the same for all of them. So you, here in this case, you are saying, I want this Ubuntu SSH image, and I want, let's see, or here the Jenkins slave. I would set the labels, and I can set all sorts of all the different options that Docker allows me. So, but the important part are labels. This is the label that you're going to use in your jobs, and the image. So every time you use a job with this label, Jenkins is going to start an agent based on this image. So this is how the jobs get matched to the cloud. So on the pipeline, you can define Docker images. In this case, Maven 339. You can pull images. You can use custom registries in pipeline to push your images there, private images. And then you can run commands inside those containers created with those images with Maven. It would be with docker.image, the name of the image, .inside. In this case, it's already defined. And also, you can build images with the docker.build. And .push allows you to push the image. There's also a new Docker plugin that was just released, the version 1.0, this week, created by Nicolas Delouf, that allows you to use any Docker image without needing Java, and allows you to have side containers, like grouping containers. And I played a little bit before this week, before this talk, and basically allows you to define multiple containers. And from one to another, you can execute commands. And in the pipeline would be Docker node, and it would be more or less the same idea of docker.inside. But in this case, it doesn't. It uses the Docker exec API directly. It doesn't go through the normal Jenkins agents. The Jenkins Mesos plugin allows you to do very similar things. Provides you a cloud that will start slaves in Mesos. And because Mesos supports processes, not only you can start Docker images, but also processes. So you can start Jenkins agents that are just processes. So again, this needs an image that includes Java to run the slave jar. And you can also do some tricks to run Docker commands from the Mesos plugin. Very similar configuration, all of them, all of the plugins. You just point to the Mesos master, where in this case it's using Zookeeper. It's like a high availability URL, where you say 3 different Mesos controllers, Mesos masters. In this way, if one of them is down, it can talk to to any other. And you set the credentials, and this will allow you to define the Docker image, define the labels, and same thing as before, and a lot of different parameters. Whenever a label matches your job label, a new agent is going to be created dynamically. You can set environment variables, you can set memory limits, you can set the CPU limits, and so. And in order to use the Docker, you need to do like if you ever try to run Docker from a Docker container, to run Docker commands, what this example do is mount the Docker host sock, so you can connect back to the Docker host server and execute commands in there. So it's a little bit of a hack, but allows you to run because the agent requires Java. In this case, what I'm doing is I'm creating a node that has access to the Docker host daemon, and then I'm running an image that has Go, the Golang. It reuses the Golang image. So instead of installing Java and Golang in the same image, I can do this trick, mounting the right things in the right place to run an agent, and then from that agent execute commands in Docker. And the Jenkins Kubernetes plugin, again, allows you to run dynamic agents. And in this case, it runs them as pods. And just recently, it was merged the multiple container support. So you can have multiple images. One is going to be the JMLP agent. So that's going to be the one that is going to talk to Jenkins. And then you can have any other images in there where you can execute commands. And there's pipeline support. That is, the PR is just is being reviewed, and it's going to get in as soon as possible, as soon as I have some time. And you can do things like this. I don't know if you can see it well enough. So the syntax is probably going to change to be a lot simpler. So in this example, what I'm saying is I want a container that is JMLP because that's necessary, and then another container Maven and another Golang container. And I'm defining these templates. And what I'm saying is like, OK, now in this slave, which is basically a combination of 3 images, 3 containers, go to the Maven container and run a Maven clean install, and then go to the Golang container and do a run and make command to do the Go building. So this way, with one in the pipeline, I can define both what images I want and what containers, how many containers do I want, and then in the pipeline definition, I can execute things in any of those containers, and the workspace is shared across all of them. So this allows you to do more powerful things and reuse more and more Docker Hub images, because now, yeah, you don't need to install everything in the same image. So as a recap, you can create the dynamic Jenkins agents in all of them, all of the 3. And typically, it's going to be using JMLPS Life jar. So the agents connect back to the masters. So in some cases, you may need to use, there's an option to use tunneled. The Jenkins agent allows you to set this up. So if you need to connect back to Jenkins, instead of putting some public IP or public DNS, it can go through the internal in the cluster. So this is something that you may want to do or may have to do. And they all are using the Cloud API, which is not ideal. A lot of people notice that agents may take a little longer to get provision, maybe 1 minute, maybe 30 seconds or so, because this API in Jenkins was created for more like VMs in the cloud that take longer to start and longer to shut down, and you wanted to reuse them. But there's work going on into creating a new API that can be optimal for containers. And also, the agents can also have more than one executor. Typically, with containers, you just want to run this job and then kill the container. But you could do all sorts of other things. And this would be the one-shot executor. And there's some work going on in there to have that. Like, just run this job in this container. When it's done, just kill the container. Don't reuse it. Don't do anything else with it. So with that, that's all I wanted to say. I think we're running out of time. If you want to catch me, well, I'll be around here or at the cloud bit. Thank you.